Hey guys, welcome back. Today we are on chapter 2. So we're going to do 2.1, linear and quadratic functions. And so we're going to be talking about polynomials, labeling them by degree, and your leading coefficients, and talking about just basically, specifically linear and quadratic graphs and how they're transformed, and basically finding equations and things like that. So let's go ahead and get started. So for a polynomial, you're going to have this lovely thing right here, and it's going to basically, what it's saying is if we have f of x, we have a function, we have n is going to be a non-negative integer, and so that here is that degree n. It's a non-negative integer, so it's going to be 0, 1, 2, 3, 4, and it's got to be an integer, a whole number. And then a sub n cannot equal 0, a sub n, and then we have a sub n minus 1, whatever, but your a sub n cannot be 0, and then your n is your exponent that is called your degree, and it's a non-negative integer. So we look at two things for this polynomial. The first thing we look at is the degree, and that is n, whatever number, and it's the biggest exponent. Whatever the biggest exponent is, that is your degree. Okay, and then if we look at a sub n is the number that's in front of the variable with the highest exponent. Okay, and that's your leading coefficient. It's the biggest, it's the first number right off the bat, right after the equal sign. So it's your leader, it's your leading coefficient. A zero function is f of x equals 0. It's a polynomial function, and it has no degree or no leading coefficient. So what we're going to do is we're just basically going to identify if something's a polynomial function or not. And if it's not, we're going to say why. If it is, we're going to list the degree and leading coefficient. So first, we have f of x is equal to 4x cubed minus 5x minus 1/2. Okay, so our leading degree, we do not have any non-negative exponents. Okay, and so our biggest exponent is this 3. And so first I'm going to say, yes, it is a polynomial. And then our degree is 3 equals 3. And then our leading coefficient, I'm going to say LC. Our leading coefficient is the number out front, which equals 4. And it's the number that's in front of where the degree is. Okay. B, we have g of x is equal to 6x to the negative 4th power plus 7, okay? Because of this negative 4, that is a negative exponent. We need a non-negative. So, no, it's not. The degree is a negative exponent. Okay, let's look at C. We have h of x is equal to the square root of 9x to the 4th plus 16x squared. Okay, so that is raised, this whole thing is raised as being under the square root, which is the same thing as being raised to the 1/2 power. Okay, we cannot simplify that because this is a binomial. We can't simplify the 9x 4th plus 16x squared because they're two separate things. And so no, this is not, because 1/2 is not an integer. So no, 1/2 is not an integer. And by that, it's just like even the square root is not, I mean, you can't have a square root exponent. D, we have k of x is equal to 15x minus 2x to the 4th. Okay, yes. All of those are non-negative integers. And then, so if we look for the degree, it's not going to be this one. It's going to be one with the highest exponent, which is this 4. Okay, so yes, your degree is 4. Equals 4. And then our leading coefficient is the number out front, which is a negative 2. Okay, and that's all I got to do. So let's talk about, polynomial functions. Like I said, today all we're going to be talking about is linear and quadratic. So our linear has a degree of 1, which is right here. Has a degree of 1, which is right there. And then quadratic has a little 2. Little 2 makes a u, and your degree is 2. Okay, if there is no degree or exponent, then it's just a constant number. And in the zero function, the degree is undefined. Okay, 2.3 we'll start talking about degrees higher than 2, but for today we're only going to be talking about lines and quadratics, which is parabolas. So lines and parabolas. So linear functions and their graphs. So we've kind of talked about, we've done this, okay? We haven't done it into the pre-calc notation though. This is a more advanced way to ask what it's asking. But at the bottom, the end of the day, bottom line, we're going to be doing the same thing that we did in P3 and P4. So let's look at exactly the properties of a linear function. And so we know that a linear function is y equals mx plus b. Okay, that's the equation of a line. And so that's the same thing. The more advanced way would just be our f of x is equal to ax plus b, where your a represents, you know, if it's going to be a negative slope or a positive slope. It's a reflection, and so it's just a way, it's the same thing, it's just a different, more advanced way of looking at it. The two things that we're going to need is slope formula, and we're going to need point slope formula. Okay, so hopefully you have those down. If not, write them down, and let's get started on an example. And so what we're doing is we're finding the equation of a linear function. So we're finding the equation of a line, and so, you know, back in Algebra 1, Algebra 2, finding an equation of a line, that would say y equals mx plus b. That's all fine and dandy, okay? Now we're going to be talking about, we want the function of that line. And so instead of saying y equals, the fancier way, the more advanced way is f of x. So we're looking for f of x equals mx plus b. Okay, what's nice about f of x, and the reason why that's more advanced notation, is because we have a function f, we have a line f, and you can evaluate f of x as certain inputs to figure out what your output would be. And so if we have the linear function f such that f of negative 1 is equal to 2, so what this says right here, this negative 1 is your input. If we input negative 1 for our x value, the output is our y value at 2. And so we can say f of negative 1, we know that negative 1 is the input or the x value. And then that equals 2, that 2 is our y value. You can leave it like that, or you can even say negative 1 comma 2. Okay, but this f of negative 1 is equal to 2 is the more advanced notation that we're going to be using in this pre-calc, okay? And then f of 3 is equal to negative 2, same thing. So if we evaluate the same function f, but at 3, so now our x value is 3. Our output is negative 2. And so this would be like x. So this would be x1, y1. This could be x2, and this could be y2. Okay, or we can think of 3, negative 2. So we still have 2 points, and so basically we're looking for the equation of this function. So f of x is equal to ax plus b, f of x is equal to mx plus b, and so let's find our m and our b. M is slope, b is y-intercept. So our slope is y2 minus y1 over x2 minus x1. So we need to find the slope between those 2 points, okay? And so we're using that, we're gonna plug it in. We're gonna say negative 2 minus 2 over 3 minus a negative 1. Okay, negative 2 minus 2 would be negative 4, 3, and that's a plus 1 would be a 4. So that would equal negative 1. Okay, so we have our slope, our n is negative 1. Now let's talk about how to find the b part. So we know that our slope is negative 1 and it goes through one of those points, so we can use point slope formula. Okay, this is slope formula. This point slope, so we have y minus y1 is equal to n times x minus x1. And so we can plug in our n, and we'll say x1 and y1, we'll just use those points, okay? If your math is correct, it doesn't matter which point you use. So we have, I'll just use blue. Y minus y1, which is 2, is equal to n, which is negative 1, times x minus x1, which is negative 1. Okay, so now I just plugged it in. This is like a positive, okay? So we have y minus 2 is equal to, we distribute, so negative 1x, negative 1 times 1 would be a negative 1. Okay, add 2 to find our b, so we get y is equal to negative x plus 1. Okay, but now we're not looking for y equals, we're looking for the linear function f. So instead of saying y equals, we're just going to say f of x is equal to negative x plus 1. F of x is just the fancy way to say y. And so there's your answer. So still we're looking for y equals mx plus b. It's just we're given our x and our y's in a fancier notation. Okay, now let's talk about correlation. And so if we have a scatter plot, if we have data that we plot, there are 5 different types of correlation. You can have a strong positive and a weak positive, no correlation, or a strong negative and a weak negative. Okay, and so think about your slope. If it's negative, it goes up from left to right. Same thing with correlation. So if we had this scatter plot and we drew a line of best fit, it's pretty easy, well, minus the fact that it's not calibrated, but it's pretty easy considering that the points are pretty close. Here, our points are more spread out, so this is a weak positive. So strong positive, weak positive, still going up from left to right. Okay, little or no linear correlation, so that's where your scatter plots are just kind of everywhere. You can't see if it's going up from left to right or down from left to right. And then here we have a strong negative. The dots are kind of closer in together, and then here it's still negative. It's going down from left to right. It's just wider. Okay, so those are the 5 different types. So now let's talk about quadratic functions. Quadratic function is, we talked about back in 1.3, about f of x is equal to x squared is a parabola. And so it goes through the origin at 0, 0, okay? It little 2 makes a u. And so we are going to be talking about translation, reflection, stretches, and shrinks based off of this, okay? And so we did this, I think in 1.5, talking about translation and transformations. We're just going to utilize that information and, prepare into here. So transforming the squaring function, which is just a quadratic. And so to describe how to transform the graph of f of x equals x squared into the graph of the given function and then sketch its graph by hand. Okay, so A is g of x is equal to negative 1/2 x squared plus 3. Okay, so from here to here, there are 3 different things. We have a negative, we have a 1/2, and we have a plus 3. So we should have 3 different transformations. So the first, this negative, if it's a negative, it is flipped upside down. It opens down. Okay, so that means it is reflected across the x-axis. Okay, the 1/2, okay, if this a value, if a is greater than 1, it's a stretch. And if a is between 0 and 1, it's a compression. And the next slide, we'll talk about, we'll go into deeper labeling details for you guys to put in your notes. And so since 1/2 is between 0 and 1, this is a compression. So it's a compressed by a factor of 1/2. And then lastly, we have a plus 3. Okay, that's not in parentheses with that x. That's at the end. So that's a k. That's a vertical transformation 3 units up. So vertical shift 3 units up. Okay, and that's it. So let's look at B. We have h of x is equal to 3. X plus 2 squared minus 1. Okay, so we have 3 transformations here. So this 3, that's your A, it's greater than 1, so it has a stretch by a factor of 3. Okay, this plus 2 is inside, it's inside that grouping, and so that's like the opposite, it's plus 2, so it's actually to the left, horizontal. So horizontal, shift to the left 2 units, and then the plus or the minus 1, sorry, is your K. That is on the outside, that's at the end, and so that's down, and that's your vertical shift 1 unit down, if I could spell. Okay, so I have all of these written down. I'm gonna look, because the next slide actually graphed these. And so if you want to check them in to decimals, that's fine. Okay, so if we looked at this, if our blue is our original and the red is the transformation, so blue is y equals x squared, or f of x equals x squared. It's reflected across the x-axis, flipped upside down. It's compressed by a factor of 1/2, and so that means it's wider. And then a vertical shift 3 units up, so it's up. Okay, and then here, it's a stretch by a factor of 3, and so that means it's skinnier. The numbers are stretched up higher, it grows faster. Horizontal shift to the left 2, and then a vertical shift 1 unit down. Okay, so left, down, and it's skinnier. Okay, and so based on that information, we're gonna I'm gonna basically go over this more as far as how to put it, this part, okay? So this right here is vertex form because it gives you your vertex at HK. And that is your turning point, that's like your maximum or your minimum. And then your vertical, your axis of symmetry is at x equals h, okay? This part, I don't like, that part right there. And then if A is greater than 0, the parabola opens up. So if it's positive, it opens up. If A is less than 0, so negative, it opens down. Okay, so if we have, again, f of x is equal to A times x minus h squared plus k. So this A, if A is greater than 1, it's a stretch. And then if A is between 0 and 1, it's a compression. So I'm going to put that there. And then we also said if A is positive, think about like if A is a positive, if positive people, they're happy. So it looks like a smile, it opens up. Opens up. Okay, and then if A is negative, it's a frown, it's sad, open down. Okay, and that right here, if it's a negative, that would be a reflection across the x-axis. Right there. Okay, H is your horizontal. Okay, I'll put in red. Okay, the positive H, it moves to the left. And if it's a negative H, it moves to the right. Super easy. And then K, I'm going to go over here. This is vertical. If it's a positive K, it moves up. Negative K moves down. Okay, and then whatever H is, okay, remember, drop your number, flip your sign, so it's always opposite. And then whatever your K is, that's your vertex.